Okay, good afternoon. What we're gonna do today, so far we have three lectures, and we're gonna review what we have learned so far from those lectures. And I have given you some tasks at home and some class tasks as well, and we didn't do due to the shortage of time. So this class we organized in a way that we're gonna recap everything. So um, first of all, sorry. Thought is in presentation mode. Okay. Why do we need MBSE? What is your understanding in last 3 weeks? Feel free. Like there is no right or wrong. Feel free. If you start from here, then yeah. Well, okay. I think it's good to write it down. Okay. So I think I can write it down. Then I will share those with you guys. So okay. So I think stack chart. No. Okay, so first is this is stack chart. Okay, from you. Okay. So same, yeah, no problem for you.
The process of using some well-defined models.
Process of what? Mm-hmm. Very good. From you.
Why we need MBSE?
No, I think we will go in order. Then I think you are the last one. I'm asking you. Yeah.
System engineering when the needs change.
Okay, so
when the needs change of the
from the customer.
From the customer, yeah.
So I think you were meant to say to capture customers' need, right?
Yeah.
Okay. Okay, from you.
It's a simplification of a real system, so
Yep.
it's easier to describe.
For you.
I think it's a way, but how to design, or it helps to design and make decisions about how to design a product or what you can do with the product. And so it's kind of a tool, or describes the whole way how you could go to solve such problems. Like to design a product, it helps on which steps you have to think about to do.
Okay, so I got I got two things, so tools and steps. Good. One more. Okay. Then I think you are the last. You see, like the question is now, why do we need MBSE? Why we need this? Why it is necessary? Because there are other way to design a product, right? So why we need to introduce model-based systems
For communication.
engineering?
A lot of different.
So communication. So bring rational understanding, what I understood. So like everybody understand the same thing. So okay. So I think we can call this one rational understanding. Okay. 3-6. I think I'm losing one. Didn't I write one? Okay. So your one is stack chart. Okay. Yeah. More or less all are correct, but I understand differently. I think it is more than the structure and everything, because the structure, process, capturing customer needs, everything we can do with systems engineering. So listen this one carefully, because don't mix up systems engineering and model-based systems engineering. They are more or less nowadays almost same, but it is not really same. Model-based systems engineering is actually, we are digitalizing the systems engineering way. Because previously, let's say in the first class, I told you how the systems engineers are working. So they are doing everything, let's say, with pen and paper. Maybe they are using some, I don't know, some tools. They are also making models, but those models are not dynamic models. They are static. And static, what's the problem with the static model? We cannot really exchange information, like one model cannot exchange information with other models. Because in the product life cycle, we are using more or less, I don't know, 50, 60 tools. And each individual tool has different, they're using different, let's say, if I tell in this way, digital tools is better, because let's say some tools, maybe they're programming in Python, some tools they're programming in C#, C++, I don't know. And overall, like when you try to engage one tool with another tool, they cannot exchange information. They cannot they're like same like engineers, how you told like when the rational understanding, like one engineers understood what the other engineers are telling, right? So we need something that we need some kind of models that exchange information between the tools. It's not about like the structure and everything. This is actually like in model-based systems engineering, you can do it efficiently, because one single tool you can use for many purposes. But previously, systems engineers were doing things like one with Excel, one with MS Word, I don't know, one with Python, I don't know. So now they try to bring everything into one place. So that's the thing, like why we need systems engineering, sorry, model-based systems engineering, because we want to digitalize the way of system design or way of product development. So that's the main reason. Is it loud and clear to you guys? Because this is really very uh, I would say very critical thing, because when you are reading some books about model-based systems engineering, they are trying to give different view rather than giving some previous background, like why we need this one, and how they're describing it seems like, yeah, we wanted to do all those things, but we were previously doing all those things. Now we wanted to bring efficiency how we are doing the thing. And that's why we need model-based systems engineering that actually gives the digital model. And those models are dynamic model, not a static model. Any question here? No. Very good. So then, why do we need systems thinking? Please, I would like to actually write and like your input. I will evaluate next year when this course will be launched. I will also take the input, and I would like to evaluate like how 1 year student think differently than other year students. So this is also part of my research. Okay. So I think now if we start from the back would be nice, or systems thinking. Why do we need systems thinking? Like thinking is like anything. When we wanted to do something, we are thinking first, right? So if I ask you, like, can you help me to, I don't know, yeah, charge my laptop, then you have to think that, yeah, for doing this, I have to stand up and come to me, take the charger and put into my laptop, and I don't know, any port here for the charging port. So this you have to think, and then it does not take so much time. But when we are designing a system, we took really long time to design a system, because we have to think every single aspect of the product, like how it will function in the real life, and what could be the problem the customer hinder with. So yeah. Mm, why do we need so maybe one could be like solving problem, maybe, yeah. Not only the problem, we need to think for solving some problems. Okay. For you?
Um, make mind how components are related to each other.
Now, why I actually bring this question? I think I spent 1.5 hours, and I think next previous lecture also 5-10 minutes also with the system thinking. So I would like to understand what you actually understand about the system thinking. This is a new topic. Normally, in other engineering realm, you do not see this one like systems thinking, right? So this is a way of thinking about the problems, and the thinking. I'm not really telling the right word, then I will not get the right answer from you. So anything, feel free. Like, why do we need systems thinking? or what's the goal of systems thinking, or why why uh, why it is related with model-based systems engineering. You can think a little bit more, maybe when you are hearing the other people's answer.
Make solutions perfect for your needs.
Mhm. So it means like a proper solution that yeah, suits customer needs. Okay. For you?
Maybe you can, it's easier to focus on a specific problem.
Okay. It helps to focus on a specific problem. Okay.
I think it's a way more structured way to yeah, to solve problems or to make.
Mm-hmm. Okay. For you?
The reason about ever more complex problems.
Two?
The reason about complex problems.
Mm-hmm. To reasoning about complex product. Okay.
I think approach in product development from the problem domain
Mm-hmm.
implementation.
Mm-hmm. Very good. So I think making bridge between problem, solution, and implementation domain. Perfect. Please.
I think for just for a better understanding of several problems.
Mm-hmm. Great. So my understanding is like this is a systematic way of thinking. So I would like to uh, confirm like the stack shared way. So systematically, like normally when we are thinking, it is most of the time like very much disorder. Like it's not in order. So these systems thinking actually help us to think, step by step. And of course, it helps to making decisions. That's the That's the important thing about this. Okay. So, what is your understanding about requirements engineering? We can start from the very beginning. From you, or from you? You just replied, so from you. Very good. So a process for gathering all requirement EQ. Okay, so you.
It also to define the requirements at the beginning and then analyze it.
Okay. So
The requirements are
define the requirement and verify. I think verify and validate both human. So it's big V and V. Okay. Yes, please.
Step by step way to organize your developing of some requirements. So if you have maybe a program
Carry on, yeah.
which still now can solve your requirement, you use this. So you have the resources you have use, and you don't have to make it use or
okay. So how you gonna manage your resources?
Yeah.
Okay,
Yeah.
so what's the problem with requirements? Okay, so another one is resource management. Perfect. You? Okay. No worries. No worries. Take your time, please. Yeah. Yeah. Very good. Okay.
I think it's a way to avoid misunderstanding, to communicate what the thing you're designing has to do, and that all speaks about the same thing and not that some think about something other than the other.
Avoid misunderstanding. And the second one?
Yeah, I think yes, that's all all have the same information to think about.
Okay, so all people are in the same page.
Yeah.
Same page, okay. So all are same page. Perfect. Yep.
I think the conversation of the solution and the needs of the stakeholder. So validation.
Okay, yeah. compare the solution. Yeah.
To define the target.
Yeah.
I want to
Yeah.
sell my product.
Target group means what?
Are they child or are they grown up? Are they girls, women, and something?
Yeah, I would say stakeholders. I think this is better because
But stakeholders also the guys.
yeah, they are they are. But here actually with requirements engineering, you have to connect with everyone, right? So it's not a single people; it's a group of people, but they have different ethnicity and I don't know. There are many groups actually. So if you only connect the customers, then maybe you lose something because you also need to consider what your fellow mates also thinking about those requirements. Let's say you bring really very cool requirements, but this requirement is unattainable because the technology and all other resources what you have is not really feasible for the requirements, but your requirements is really needed for the customers, but it is not possible. So you have to also think rationally, I think. So that's the thing. But yeah, it is also not wrong if you are only considering the customers, but it is wiser if you think you could connect every single stakeholders, because for a successful product development, only the customer is not playing the role. Also, the other stakeholders also playing the roles. You know.
Talk about the needs of the product. The people who need the product who want to use it.
Yeah. This is not wrong.
If I bring a magazine with just price, then just trials. You don't have to talk about grown up.
Yeah, that's right. But you see, you need to also specify the requirements. Let's say maybe in requirements elicitation, you have, I don't know, 1,000 of requirements, and all are not really feasible for your product. So then you have to cut down some requirements, right? So you have to make the specification. If you see some products, let's say any car or any aircraft, you will see very few specification is there. And you see, like if you consider a aircraft, then you might see the wingspan, the engine, and what do you call the range of the aircraft, like how far it can go, and maybe the volume of the interior. So these are the minimum, and maybe some equipment what they're using for the navigation systems. So this actually not all, and they didn't come those specification. You see, so they have to actually I don't know, maybe millions of requirements they have gathered, and then they slice those requirements and made this one. So this is a process. So what the other guys are telling, the first one is a process for gathering all requirements. So it's a process. It is not only the like. What you are telling, this is actually the part of requirements elicitation, right? But this is very good. you argue on that particular part. It's very good. So I think now everybody also understands. Any question here? Okay, then I think this is the last question, but I think this is very tricky one. Do you see any fine line where we could segregate, like, we could make a difference between the requirements engineering and systems thinking? Is there any way that we can segregate these two? Let's say it's like, let's have some more discussion. Let's say we wanted to develop a product and somehow we wanted to skip the systems thinking and we wanted to do requirements engineering. And somehow, if you see the whole process of requirements engineering, then you see, yeah, somehow it's covered the requirements thinking. So, do you think this is actually needed for product development? I'm not gonna write anything here. This is I think, thought-provoking question. So you should know what is requirements engineering and what is systems thinking. Anyone? Yeah, you can start. Maybe.
As you said, system thinking is a ordered way to thinking,
Right.
and requirements engineering, we have all requirements, and then we can use for one requirement the system thinking. So it's maybe the top of system thinking. So we have all requirements, then we look in one of these, and then we start the system thinking of this one requirement.
Very good. Well defined. Tell the same thing, but why I'm asking this? You guys will memorize. Personally, it's very important. It's very important. I think we have. Sorry. Oh, on point. Okay. Okay. So you can think. If other guys are saying something different, maybe you can argue. So it's not always like you will be giving the solution, rather than you can raise some questions, raise some problems, and from the problems you try to find out the solution. So maybe you heard about the famous quote from Einstein, like telling something like, if the world is like somehow destroyed or something, and if there is 1 hour, and if somebody gives him 1 hour to solve this crisis or solve this problem, so he will take 50 minutes to think about the problems, and he will solve the problem in 5 minutes, and he will implement the problem. So the solution phase has actually 10 minutes. In product design, or I would say, even though if you're writing a publication, there are also like in the problem definition phase, you take really a lot of time. And if you understand the problem, then the solution comes. You can also ask some. I will try to answer. So, any other questions? Anything new?
I think system thinking is the tool of requirement engineering, because while requirement engineering, you get some ideas what you want, what is possible, and then you need the way, if it's doable, how we do it with system thinking. And I mean, all the time, the one side affect the outside.
Yeah, this is true. But I see it different. Maybe I'm not fully agree. It has a use everywhere. So system thinking has a use everywhere, more or less in product development or product life cycle. I think this is a tool in the solution domain. So where you can actually, through systems thinking, you can make the solution better way, more structured way. So this is my understanding about. But like when we are applying model-based systems engineering, but honestly speaking, systems thinking is like everywhere, everywhere in the product life cycle. You have to think first, and you have to do, and then you're gonna do. So the specific question is like, is there any border or is there any fine line between those two? There is a fine line, but it's hard to define. It's always shift, from one place to another. So there is a border, but it's hard to identify, hard to define. So honestly speaking, I'm glad that you guys answered those questions in the right way, and I think you guys have a really good understanding about the model-based systems engineering. So it's not always like it's not really easy. Okay, you missed something. Very interesting. No worries. But I will ask you later. But maybe this is the right time because we have almost 4 or 5 questions. So what is your thinking actually? Like you have heard about the systems thinking, requirements engineering, model-based systems engineering, right? So all the thing what we have done in the last 3 lectures. So do you think we can? It's very hard as you just came and it's hard to answer. But if you wanted to answer this question, feel free. Just read it and do you have any like overview on this?
First question: what does segregate mean?
Okay, segregation is like any border line, like to divide, segregate something like.
RE from ST.
Yeah, RE means requirements engineering, and ST is systems thinking.
Okay. And you need to
Think. You need to think. Okay, no worries. If you want to come back, after some times, feel free. Okay, so now I would like to go to the main part. In the first lecture, I gave you some tasks about the flying vehicle. So flying vehicle could be aircraft. I'd like to see, and we would like to actually discuss what you have done, and because now you will see the differences, as I have told you in the last class, that feel free what you have done is no problem. There is no here especially. Yeah. You can use, if you want, you can use the board. Feel free. Feel free, man. There are many, so which one you want? Yep.
But first, I made a list of problems I could have. With possible solutions. Yeah, a flying vehicle, a vertical movement.
We're writing it like this. VTO. So VTO means vertical takeoff and landing.
Okay.
It's the short form.
Okay. Then horizontal movement. So how can I come from A to B? How can I transport something, someone? What? And start landing. It was my last one, but it's
Okay.
So how
But
can
I think this is also nice. VTO, if you write, and maybe here vertical PL or vertical landing. Yeah, this is a good way of thinking. Yeah.
so I said, how can I fly with gas, which is lighter than air? Or hot air.
Okay.
How can I the horizontal movement with the turbine? Turbine. With the wind, or propeller. And transport with a tank or a plane or a basket, something like that. And how at the start and the landing, also with speed. So wie nennt man es? Ein Flugzeug, Turbine umtreibt. Ja, genau. Was ich braking, or I have written down a burner with gas or the hot air.
Maybe we can.
Or yeah.
Somehow you reduce graphs and you try to increase the weight, maybe. So yeah.
So maybe someone knows which solution I will take, the hot air balloon. So this is my main system. Then I said I have a basket for transport, a balloon, Yeah, so the basket has a case. And normally a basket is with ropes. Then the balloon is the balloon and a net made of ropes. So net, and this gets here ropes, and the balloon itself. And the burner has the subsystem of valves, gas tank, burner, and so on.
Very good.
So that's my
Yeah.
top to bottom.
Yeah. Very good. Thank you very much. It's like after last class, I would say it's very well thought out. So, have you done anything? I know you have done something, right? Please do come. This is really interesting, like how you guys are developing the way of teaching is very interesting.
I also came with the problem and solution domain. I said my vehicle should fly, but also be able to go on the ground. Because the projector is
Okay.
but then I also said are there any legals to think of legal authorization or to develop such a product? What's the range? The vehicle, the flying air vehicle should cover the capacity. And also how did it land and start? Yeah, and then I thought of these problems. Why we need any kind of propulsion. The legal yeah. To know the law, or study the law. The range defines our tank or the weight.
So you mean like fuel capacity?
Yeah. Yeah, for landing, we will need a in place, like airport equipment or for the capacity, like how many passengers should be carried or freight. This is the dimension of the vehicle. And for this solution, I would also
Make something like this. Yeah.
like this is something I didn't
Do what you didn't do.
no.
Okay.
Yeah,
But
it's on and
it's
on and on.
fine. Yeah, this is actually one. This is one and one. But
one thing is also
okay. Good. I still, this is also okay because when you start to making the different subparts, it's like enormous. It's never ending process.
yeah.
It's hard, really hard. So, okay, anyone? No? No, it's fine, but so far I have seen that two guys have done this and it's good. Okay, okay, I have to go back again. Sorry. Come on. It's a little bit. Next time I'll not try. There is no. You have to press. Okay. So now is the second one. Systems thinking. This one actually I wanted to do it, but you have seen like I tried and how complicated this one. And I was trying to do by defining different engineering domains. And when I was working, I was thinking like, is this the right way? Then I thought, well, that is not really the right way from my understanding, but some other people also think that. Because without defining the total subsystems or the module or I don't know the total systems, it's hard to assign or define the domain because this is pretty much hard to understand what exactly we want. So I made it to give you guys some understanding, like the way I was thinking. So that was your way, like thinking about the solution and thinking about the problem. But I think depends on the person. So I actually try to think from the operational context because I know already this product, and I thought like this is the better way. I could understand what I actually need because there is no specific requirements. You see, the problem here, I didn't give you any kind of requirement. I was only asking you to design a hair dryer. And it's really hard. There's one single word, hair dryer. So you do not really know what to do. So therefore, I thought like I put something here, that hair dryer, and my solution is like from problem domain to solution domain. So what I wanted to drive, I wanted to drive the wax here. So this is my ultimate goal. And what I need for this hair dryer, I need ambient air, and this ambient air I need to make hot. And for making hot, I need some power. And this power is supposed to be controlled. So I need a control system. So this is the initial way how I thought out. Okay. Then I try to structure it from if you can remember the I forgot to take the picture of this one. Sorry. Let me have the picture. Okay. So from the top-down approach, I considered the hair dryer. This is my ultimate goal. Then I need a frame. So this is a universal case for anything. If you wanted to design a car, design a bike, design an e-bike, you need a structure. Then I thought like I will create two modules, and the module one module is like the heating module, and in the heating module there will be a motor fan that are many parts. We only put some parts, and the control module is supposed to have the power supply and the switch. So this is a very minimalistic design I created, and I bring one whole what do you call this hair dryer to give you guys some understanding, because if you hold it and if you design something that actually makes more sense. I understand the cover actually I took out, so I actually gave this task to all of my students, and he actually opened it up, and I don't know where I put the cover. Yeah. So you guys can carry on and see what is inside. So this is the way, very, very, introductory level type of design. But you can also think in this way. Okay. Then, so the third lecture, we have the, what do you call, the process, and it was a part for the home. So you guys okay, who has come? Please come to the board if you want, or other than I can write down for you. No problem. Anyway. Anyone? Have you done anything? Great. Then feel free to come in. Have you done something? Please do come, man. Or I can write for you. No problem. Tell me.
Task was to
Combine these two process.
Yeah, first step was to plan from the first one because I find the overview of the main tasks is important. So,
Right.
then the next step is to visit.
Yeah.
And the next step was specification and
I think if I change the border, it would be nice. No. Sorry. Specification. Then
B&B.
same in the same phase, or you have different phase.
5 different.
Okay.
And
Okay.
the managing of
It was very simple. If you didn't do that.
On the elicitation. It would be the first step.
Sorry?
Because for combination, I think the first approach there was the planning and establish. But I think it should be combined.
Both.
Elicitation.
So the plan and elicitation is.
Yeah. I think it should be one step.
Okay.
Then to analyze. And this requirement should be then verified and validated.
Verification. For you?
Well, I saw the product. I guess I didn't quite get it. I mean, we can always group 2 phases into one, or we could group all 4 phases into one for requirement.
That's true. Right, you know, like when you are making some mistakes, not only the diagram, you also need to have some production, and there you're gonna write like the task I have given to you about it, and honestly speaking, requirements is like the heart of everything, especially in product design and development. If you are not creating the requirements properly, then everywhere you will see the mess. And I have shown you the graphs. Even though recently I have seen one paper, they describe failure of NASA, and I don't know, like 55 or 59 projects they analyzed, and they have seen like they actually applied the probability. They use the systems engineering where how many and if they use model-based systems engineering, then how many will successful, and if they do not use, then how many projects will be successful. So yeah, it's really important, and more or less they somehow focus on the requirements engineering part very much. So,
Yes, I would do the second case, but add an arrow from BNP to plan and that is an arrow from right to left.
okay.
Yeah. They have to manage, so if validation isn't correct, to go back to planning and elicitation. Start from the beginning.
So then again here.
Yeah.
Okay.
I would do it similar to the first one. At first, I would do planning, then elicitation, and then kind of prioritize my requirements, and then managing for the requirements.
And the BNB?
Also,
Okay. Yeah.
managing.
Okay.
I would do first also planning, so which goals, boundaries, resources, activities, and needs. Then I will do a kind of conflict resolution. So what do you mean? I mean, I will define a kind of strategy first, how we could handle errors or what when changes, when we have to make changes, which plan we use or how we could solve conflicts.
So this is in the planning phase, right?
That's in the second phase. I call it conflict resolution.
Okay. So plan, then conflict resolution. Right?
Yeah, so
Okay.
and then the third phase is also the education process to get information about the
Consultation. I would like to make a new one, like a different color. Elicit
then also the specification to classify my the requirements and to roll them out, prioritize them. And the last thing also being
Great. Okay. So here I have a problem because the conflict resolution is more or less, I understand, as soon as you have the requirements or the needs from the customers.
here it's more like a plan. What if in the later steps there are kind of
Okay.
changes also how I would handle this.
So this is somehow then the planning section, because
Yes, yeah.
planning is more or less, you have to define how you're gonna handle everything. Like if there is conflict coming in, if you need to what do you call, deduct some requirements, if you need to add some requirements, then if you need to make a team, also what are the qualification those people will have. So those are the things you have to, this is the part of planning. So you do not need any other step for the conflict resolution. Okay, but you have thought in different ways. It's very good. Yeah.
First planning and research, and then processing. This really big process to do a new.
Let me write it down. Then first plan. Then
like processing, is it possible what you think like can we build our can we build our product, like processing the product, make it physical?
without having the requirements, how you gonna make the physical product?
Or, like,
It's very early stage, you know, so you do not have anything. So it's, you can consider a blank page or a, you know, like empty board, blackboard, you know, or a green board, something. So you do not know anything. So you have to first collect the requirements from your customer or from your stakeholders, and then you need to process those. So it's something like you can consider, let's say, have you seen like how people are making knives, you know, for cutting, like, you know, the knives, the kitchen knives. Have you seen how people make from a or sword? You see, they took some kind of metal, I don't know, any kind of metal, and they first heat it up, then hammer it, and making the shape, right? So requirement engineering, more or less, this is the way you take something very raw and then prepare it like, right, yeah, making the shape. That's right. But yeah, I would like to write. It's no problem. I'm just discussing, so it's no problem. Requirements.
If it the requirements are not so VMD, and I would go make an arrow back to plan or process.
Okay, so you want
maybe I had the arrows in my mind.
okay. So I would say this processing is something like the analyzing.
Actually, I use the word analyzing for design quasi, because I was not analyzing.
So first is analyzing.
Yeah, because I saw it like I need to analyze my goals or my point of thought.
Mm-hmm. So it's a
word, I use the word
plan.
That is it.
Yeah, it's more or less than it's plan. So plan. And
I would step up to elicitate, get the
Elicit?
requirement. And after that, I would make a mix between verification of the BNB and analyzing, because now I use the right word.
My understanding, analyzing and verification and validation, analyzing and verification is same, in my understanding. But so far with the text, what I have seen, they are and you know, telling the same thing almost.
Yeah.
So
That's it's more. And then after BNB, arrow back to LSP.
okay, like this.
Yes, and in the second turn flag, in the second round, I would end this remote into specification. So after BNB again,
Yeah.
to specification. That's it.
Okay, Good. So this is very nice to see that you guys thought differently. Okay. So I'd like to show you how I thought. It's almost align with your thinking. There's not much different, I would say. So I think this is the way. It is not maybe the right way, but how I understand this is the right way. Like plan, you have to have a really good plan for the whole requirement gathering. Then you have to elicit, and the elicitation is like how you gonna gather all the requirements, and when you are eliciting, it is actually the raw requirement. It is not really like how I told raw materials for the kitchen knife. Then I think analyze and specification supposed to be in one place, because without analyze you cannot specify what are the requirements. So I think the analyze and specification would be the right word, quite explicit. And then is validation. So I put the analyze is actually the verification, and validation is down because validation is actually the work of the stakeholders. This is quite interesting. Validation is not the work of a systems engineer. It is the work of the customer who actually gave you the task. So yeah, this is my way of thinking. So this is the end of the task, and there is no task. I think you will be happy to hear that. And next week, Sabine will provide a tutorial for enterprise architect. And the next class you will get your class assignment. And I believe the assignment would not be very difficult for you guys, because how you guys all performed today, I think you have a good understanding of MBSE. And yeah, this is all. And if you have any questions, then I can answer, because still we have 10 minutes left. Feel free if you have any question. Even though if it is outside of the topic, I don't mind.